Hey Pre-Calc students, Mr. Mitchell here. We're going to take a look at rational function today for Pre-Calc. And we've got some definitions here. Rational function, what an asymptote is. We've got vertical and horizontal, and then we also have slant asymptotes. So just some things that we need to be aware of. We'll talk about going over those in a problem. So let's take a look at number one here. This is a rational function. It's a polynomial over a polynomial, and we need to find the domain, vertical asymptote, and any horizontal asymptote that they have. So when I think about a domain for a rational function, I'm really focused on the bottom. I take a look at the bottom, and what is going to make the bottom equal to 0? Well, 0. So what makes the bottom 0 is x equals 0. So my domain can be anything but that. So there's different ways to write that. But using interval notation, we have negative infinity to 0, union 0 to infinity. So that's our domain for this particular problem. There's other ways to write it. Another way to say it, you could just say x does not equal 0. We want to stay with the notation of intervals, because that's what you're going to need to be able to use in regular calc. So this means the same thing as that, but we want to write it this way. So to find the vertical asymptotes, once you find your domain, your vertical asymptotes are the same unless there's any holes, which we'll get to that later. There are no holes on this problem because the top is just 1. So whatever your domain restrictions were, 0 is a domain restriction, that turns out to be your vertical asymptote. So whatever your domain restrictions are, that will tell you what the vertical asymptotes are and any holes that you may have. Now with horizontal asymptotes, there's 3 possible scenarios. You look at, I know this is a little confusing to see, but you look at the powers on the top and the bottom. So when the power on the top is bigger, you have no horizontal, then you have to look for a slant. If the powers are the same, you make a fraction out of the coefficients. And if the power on top is smaller than the power on the bottom, it's 0. So in this case, the power on the bottom is bigger. So our horizontal is y equals 0. Okay, well, let's go practice another one. So number 2, we're going to still find the domain, vertical and horizontal asymptotes. So to find our domain, we're going to take the bottom, and we're going to set it equal to 0. And then we're going to solve that. So if you factor it, you get x plus 1, x minus 1. So you get 2 answers. So we're going to write our domain then for this. The domain is negative infinity to the first number being negative 1, union negative 1 to 1, union it's going to be 1 to infinity. Okay, so these are supposed to be U's. I know it's a little difficult to see that by the way I'm writing, but that's our domain. So then what we need to do next, before we look for any verticals, we do need to look to see if there's any holes. Are there any common factors on the top? So the top doesn't really factor. The bottom factored into this. There are no common factors, so there are no holes. We always want to check that, because there could be a graph that has a hole, not a vertical asymptote. So the vertical asymptotes are the domain restrictions, so it's just x equals 1, x equals negative 1. Whatever you restricted in your domain becomes your vertical asymptotes. Then we look for the horizontal. Now, we already talked about the power on the top being bigger than the power on the bottom. That means there's no horizontal, there's a slant. If they're the same, you make a coefficient fraction. And if the power on the bottom is bigger, then you make then it's just 0. Here the powers are the same, so make a fraction. So you have a coefficient of 2 and a coefficient of 1. So that's just y equals 2. Let's try letter B. So we need to factor the top and the bottom when we get the chance. We definitely have to factor the bottom first to find our domain. So we're going to factor the bottom. What multiplies to x squared? X and x. What multiplies to 6? 3 and 2 or 6 and 1, we have to add or subtract a 1, so it's got to be 3 and 2. Signs are different, bigger one's negative. So my domain is going to be negative infinity to negative 2, union, negative 2 to 3, union, 3 to infinity. And then we have our verticals that we're going to have to find. So before I do that, I do want to factor the top to see if I'm going to have any holes. So I factor the top, if it can be factored. If it can't be factored, then there's definitely no holes. So it's x and x, what multiplies to 2. It's got to be 2 and 1. Signs are different, bigger one's positive. Uh-oh. So before I do my verticals, I am going to have a hole. So I'm going to indicate that. Even though the directions don't say to find any holes, I always indicate that. So the hole is at x plus 2, so that means the hole is at x equals negative 2. That means the other domain restriction is x equals 3. So I had 2 domain restrictions, negative 2 and 3. I had a hole at negative 2 and then a vertical at 3. Horizontal asymptote, look at the original function, don't look at the factored one. That could be confusing. Powers are the same. Make a fraction out of the coefficients. So there's a 1 here and a 1 here, so it's 1 over 1. Okay, number 3. Now we're basically doing the same thing except for we're going to graph. So I need to find my domain. The bottom's already set equal to 0. Or I'm sorry, the bottom's already factored. We're going to set it equal to 0. And it's 2. So I'm going to have a domain restriction at 2. So negative infinity to 2. Union 2 to infinity. That's my domain. Vertical asymptotes. Do I have any holes? No, there's no holes because there's no common factors. So you can write holes, none, just to get used to writing it. And then you have horizontal. The power on the bottom is bigger, so it's y equals 0. Now we're going to get into graphing. I'm going to do my best here to graph this. But I have a vertical asymptote at 2, so I'm going to draw a dotted line at 2 on the x-axis. I have a horizontal at y equals 0. So there's where my graphs look. Now I can use my calculator to definitely help me graph it, but I got to make sure it is a function. It has to be a function, but I can plot some points. Some easy points to pick are to find the y-intercept. So if you plug in 0 for x, you get negative 3/3. Plug in 0 here, you get 3 over negative 2, which is that. 0, negative 3.5, 3 over 2 goes here. So that kind of tells me this part of the graph's down here. The other part is either up here or over there. So the only thing else you can do, plug in a point over here. Like, let's just plug in 3. So you need to plug in some points. Plug in 3. So if you have 3 over 1, 3 over 1 is 3. So I plugged in 3 for x. So it's 3 over 3 minus 2 is 1, which is 3. So that's a point. 3 comma 3 is right here. Alright. So for the sake of time, I'm just going to know that the graph looks like this. I would use my calculator to verify if I'm not going to plot more points. But it does look like that. It doesn't cross the y-axis, so I can't find any y-intercepts. So there's what my graph looks like. Okay? Take a look at the next one. So again, I got to find my domain to start. Set the bottom equal to 0 and factor it. It's x and x, 2 and 1. What multiplies to 2? 2 and 1. Signs are different. Bigger one's negative. So it's x equals 2, x equals negative 1. My domain is negative infinity to negative 1. negative 1 to 2, and then 2 to infinity. Do we have any verticals? Well, do we have any holes? We always want to ask that question first. There's not a common factor on the top and the bottom. This is what it factored into. There's x on the top, so there are no holes. So I have a vertical at 2, and then a vertical at negative 1. So I can come over to my graph. You can graph everything at the end, or you can graph it all at once. There's 2. And then there's negative 1. Then you got to find your horizontal. So power on the top is smaller than the power on the bottom. Y equals 0 all the time. Now this one would be a lot easier if I could just use my calculator, type it in, and get some points. Because I don't know where this graph is located. So let's try to practice that. Okay, so here's a calculator. We type in the equation. It's x divided by x squared minus x minus 2. Always double check to make sure you're graphing the right thing. So x divided by x squared minus x minus 2. So yeah, we're good with that. Then we hit type it in, we graph it, and there's what it looks like. Okay, we can always go to our table to get some points off of my graph. So I can get any point I want on my graph here to try to graph this thing. So it does go through 0, 0. That's probably a good point to have on your graph as well. So I go back to my picture. It does go through 0, 0. And you might say, well, wait a minute. That's a horizontal asymptote. How can it cross there? It can't cross a horizontal asymptote near the origin. It's never going to cross over here or over here. It can cross in a proximity to the origin. So looking at my calculator again gives me an idea of what it looks like. So it's this, and it kind of looks like an x cubed type thing there in the middle. So our graph's going to look something like this. It's not too bad. That's our graph. Again, we can go to the table to get a bunch of points, but for time reasons and the use of a calculator, I'm not going to just plot points by hand. I don't think that that's necessary. Okay? All right, last problem here. We've got to check for slant. It does have a slant. How do I know that? Well, I made the question, but we're still going to find our domain. Set the bottom equal to 0. You can see that that's going to be negative 1. So we go from negative infinity to negative 1, union negative 1 to infinity. Does it have any holes? Well, factor the top. Top needs to be factored, and it factors into that. Are there any holes? No, there's not. There's no common factors on the top. So there's a vertical asymptote at x equals negative 1. If you set the bottom equal to 0, I can graph that. Horizontal, the top power is bigger than the bottom, so there actually is no horizontal. So what we're going to do long division or synthetic. So you can do long division or synthetic division. It doesn't matter. Whatever your preference is. I'm going to do synthetic. So I put negative 1 in the box. I do 1, negative 1, and 0. Bring down my 1. I multiply, add, multiply, add. So what am I left with? This is x minus 2. And that's going to be my slant asymptote. Y equals x minus 2. And then I have to graph that. So x minus 2, you go down 2 and put a point. And then you go up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1. And there's your graph. So if you type it in your calculator, x squared minus 1 divided by x plus 1, it's going to look like this. Our calculator does not draw the asymptotes in there. You have to know what they look like. But that's what the graph looks like. So when I come back to my picture here, I can finish off my graph by graphing it.